let's talk about higher order derivatives. So what this is basically the derivative of a derivative. So what happens when we do that? So I want to make sure I'm pulled up so that I can know what space I'm working with. So taking the derivative of a derivative results in the second derivative. So if I take the derivative of a derivative, I get a second derivative. And if you continue, you'll get a third derivative, or a fourth derivative, or a fifth derivative, etc., out to infinity. So the derivative of the second derivative is the third derivative, the derivative of the third derivative is the fourth derivative, the derivative of the fourth derivative is the fifth derivative, and so on and so forth. Collectively, these are known as higher order derivatives, right? Just like the order of an exponent is the number, the order of the derivative is how many derivatives you've taken. So that's the basics. It's pretty straightforward if we're working with standard functions, because you just keep whatever you get out, you take the derivative. It does get a little more complicated with implicit derivatives. So we have to be a little bit careful with this and with some things that we'll learn later in the year. But for basic f of x functions, second, third, fourth, fifth derivative, it's dead easy. For implicit, though, we do have to be sure to substitute in, or plug in if you prefer, y prime after we calculate y double prime. And if we were to calculate a third derivative, we'd have to plug in y prime after calculating the third derivative. The reason for this is if you don't, then your implicit differentiation will start to give you messy stuff that you can't deal with. So we always have to pause after we calculate a second derivative, plug back in y prime. And this will be easier to see once I've done an example, but I want to make note of it now. Always make sure you substitute in the first derivative after you've calculated higher orders.